Researchers at ETH Zurich have built something pretty incredible in their soft robotics lab. A robotic hand and forearm that works a lot more like a real human hand than most robots we've seen before. The project is called RHAVCJ, which stands for Replicating Human Anatomy with Vision-Controlled Jetting. The name might sound complicated, but the idea behind it is simple. Create a robotic hand that closely mimics the structure and movement of a real human one. And it's a big step forward for the future of humanoid robots. To build it, the engineers actually started by studying the human body. They used MRI scans of real human bones to design the internal structure of the hand. Once they had that framework, they added tiny soft capsules into the joints so the hand could move more naturally. Flexible tendons connect everything together, just like in a human hand. The fingertips and palm even contain small holes filled with a super thin sticky substance that can sense touch. All of these parts are created together using a special 3D printing technique called vision-controlled jetting, which precisely places different materials exactly where they need to go. That means the whole hand can be printed in one process, without screws or complicated assembly steps. What really makes this robotic hand different from earlier designs is how it moves. Most robotic hands rely on electric motors to control the joints. This one takes a completely different approach. Instead of motors, it uses 22 artificial muscles, located in the forearm. These muscles are based on the McKibben artificial muscle design. Each muscle contains a small rubber tube wrapped in a braided mesh. When air is pumped into the tube, it shortens and thickens, pulling on the tendons and bending the fingers, very similar to how real muscles work. These artificial muscles can expand by about 30%, which is pretty impressive, while also keeping the system relatively affordable. The real breakthrough comes from how precisely these muscles can be controlled. Each of the 22 muscles can move independently, giving the hand extremely detailed control over every finger. The thumb can even touch the other fingers the same way a human thumb can, which is essential for tasks that require dexterity. The fingers can curl, stretch, and adjust their grip naturally, allowing the hand to perform a wide range of movements. During testing, the robotic hand has already shown some impressive abilities. It can carefully pick up small objects like a coin and also hold heavier items, like a 272-gram can, without dropping them. The fingers can apply about 1.95 newtons of force, which is enough for delicate handling while still providing a firm grip. And thanks to the built-in touch sensors, the hand can actually detect when it's making contact with something. Even though it's just a prototype, this technology opens the door to a lot of exciting possibilities. Robotic hands with softer joints are more flexible and less likely to be damaged if they bump into something unexpectedly. The touch sensors also give the system real-time feedback, helping robots interact with objects more safely and naturally. Looking ahead, the researchers hope to scale this technology up into full robotic arms, or even entire humanoid robots, possibly combined with advanced control systems that make them even more capable.